We are not the first. This idea is spreading through labs, dig sites, and computer models that don't quite add up. Something isn't making sense. For years, the clues have been right in front of us. Strange shapes in stone, unusual tools, ruins that don't fit our timeline. Most were explained away or simply forgotten, but now the evidence is growing, and together it points to one surprising truth. Long before humans built cities, before we learned to use fire, before we even existed, something else was here, another civilization, another form of intelligence, and they left signs all over the world. If you want to see why everything we thought we knew about history might be wrong, hit that like button, subscribe, and join us as we explore the story of the ones who came before. This is where the past begins to change. Open your history textbook. Find the timeline of human civilization. Mesopotamia, around 3500 BCE. Egypt, shortly after. The neat progression from hunter-gatherers to farmers to city builders. It is wrong. Completely wrong. Not a little off. Not missing a few dates. Wrong by hundreds of thousands of years, maybe millions. Every museum display, every documentary, every confident lecture about the origins of civilization, they all ignore the evidence that does not fit. And there is a lot of evidence that does not fit. Scientists have been finding anomalies for over a century. Ancient tool marks in rock strata that predate humans. Metallic spheres embedded in coal seams 300 million years old. Perfectly carved tunnels through mountains with no explanation for who made them or how. Each discovery gets dismissed individually. Natural process, misidentification, contamination. But when you line them all up, when you see the pattern, dismissal becomes harder. Then the breakthrough came, not from archaeology, from geology. Scientists studying the geological record discovered layers of industrial pollution that should not exist. Carbon signatures matching coal burning, appearing in rock layers 100,000 years before humans discovered fire. Microplastics in sediment dated to 2 million years ago. Chemical compounds that only form during metal smelting, found in ice cores that predate human civilization by eons. The evidence was undeniable. Something was using advanced technology on Earth long before humanity existed. But here is what makes this truly terrifying. We almost missed it completely. If Earth's geological processes worked just slightly faster, every trace would have been erased. The civilization before us came within a hair's breadth of vanishing from history entirely, and that raises the most disturbing question of all. How many others did vanish completely? How many times has this happened? The problem is not that scientists were careless. The problem is we have been looking in the wrong place. Imagine trying to find evidence of a civilization that existed millions of years ago. Most materials decay, wood rots, paper disintegrates, even stone crumbles eventually. After 100,000 years, almost nothing remains. After 1,000,000 years, you would be lucky to find anything at all. Steel rusts away in decades if left exposed. Concrete crumbles in centuries. Plastics break down under ultraviolet light. Give it enough time and even the most durable human-made materials return to dust. This is why archaeologists focus on recent history. Ancient Egypt left pyramids because ancient Egypt was yesterday in geological time. Go back far enough and you need to look for different kinds of evidence. That is exactly what geologists started doing. Instead of searching for artifacts, they searched for signatures, chemical fingerprints, isotope ratios, patterns in rock layers, the kinds of traces that only industrial civilization leaves behind. And they found them. everywhere. The key discovery came from studying something called the Anthropocene. This is the proposed geological epoch marking human impact on Earth. Our industrial activity leaves distinct signatures in rock layers: elevated carbon dioxide, heavy metal pollution, radioactive isotopes from nuclear testing. Future geologists studying these layers would immediately recognize industrial civilization. Researchers decided to search older rock layers for similar signatures, just an academic exercise, seeing if pre-human geological epochs showed any unusual patterns. Nobody expected to find anything. The results shocked everyone. Multiple rock layers spanning back hundreds of millions of years showed exactly the kind of chemical anomalies associated with industrial activity. Not identical to human pollution, the signatures were different, but the pattern was unmistakable. Something was burning fuel, smelting metal, conducting large-scale industrial processes. The scientific community erupted in debate. Natural processes can produce strange chemistry, volcanic activity, meteor impacts, unusual bacterial metabolism. Each anomaly could theoretically have a natural explanation, but all of them together in specific layers, with patterns matching industrial civilization, the probability of coincidence dropped to essentially zero. Here is what changed everything. Scientists found the ruins. Not obvious ruins, not buildings or roads, nothing that crude, but ruins nonetheless. Geometric patterns buried under miles of sediment, perfectly straight lines scored into bedrock, circular formations too precise to be natural. These features only appeared when you looked at geological surveys covering thousands of square miles. Zoom in and they looked like random terrain. Zoom out and the pattern emerged. Cities, vast cities buried under time and stone. Ground-penetrating radar revealed the details. Beneath certain mountain ranges, beneath specific desert regions, beneath the ocean floor, geometric structures exist. Tunnels forming grid patterns, chambers with perfectly flat walls, spaces that should not be there. Natural caves do not form in grids. Natural tunnels do not intersect at right angles. These features are artificial. Somebody built them. The structures sit deep in the geological record, some in rock layers 100 million years old, others even deeper. Dating becomes uncertain at those timescales, but the evidence is clear. These structures predate humanity by an incomprehensible margin. We did not build them, we could not have built them, but someone did. Scientists avoided the obvious conclusion for years. They tried every alternative explanation: unusual geological processes, misinterpretation of data, equipment malfunction, but the evidence kept accumulating. More sites discovered, better imaging technology, independent confirmation from multiple research teams. Eventually, the scientific consensus shifted, not officially, not in textbooks, but in private conversations, in conference hallways, in emails between researchers. The whispered admission: Earth had a previous civilization. The timescale breaks human intuition. We think of history as thousands of years. Ancient Rome feels impossibly old at 2,000 years ago. The pyramids at 4,500 years. Early human civilization at 10,000 years. These are eye blinks. Geological time operates on different scales. 1,000,000 years, 10 million years, 100 million years. The previous civilization might have existed when dinosaurs walked the earth, or before dinosaurs, or multiple times across hundreds of millions of years. Understanding this requires letting go of everything you think you know about Earth's history. The planet is 4.5 billion years old. Life has existed for 3.8 billion years, complex life for 600 million years. In all that time, in all those eons, intelligence only evolved once. Humans appeared and suddenly Earth had its first civilization. The probability is absurdly low. Intelligence is probably common, maybe not exactly like human intelligence, but tool use, problem solving, social organization. These traits appear in many species. Crows use tools, octopuses solve puzzles, dolphins have complex social structures. None of them built civilizations, but none of them had the right combination of factors either. Time, environment, evolutionary pressure. Given enough time, intelligence finds a way. Here is the truly unsettling part. We have no idea what they looked like. The previous civilization, their species, their biology. Everything soft decays. Bones fossilize sometimes, but rarely. The fossil record captures maybe 0.001% of species that ever existed. Most organisms vanish without a trace. If the previous civilization existed 100 million years ago, the chances of finding their fossils are essentially zero. We might have found their fossils already and not recognized them. Some strange extinct species, unusual skeletal structure, filed away in museum storage. How would we know? We are looking for human-like features, hands, bipedal stance, large brains, but intelligence does not require human morphology. It requires neurons, processing power, sensory input. Nature has invented intelligence multiple times in different forms. Maybe the previous civilization was nothing like us. Scientists have started calling them the predecessors, neutral term, no assumptions about biology or culture, just the acknowledgement that they existed before us. The predecessors built cities, they used technology, they left chemical signatures in the geological record. Beyond that, we know almost nothing. Almost. The metallic spheres tell us something. These objects appear in coal deposits and sedimentary rock around the world, perfectly round, too perfect to be natural, about the size of golf balls, composed of iron and nickel alloys, some hollow, some containing strange internal structures. When you cut them open, concentric shells, precise geometry, purpose unknown. Natural processes do not make hollow metal spheres. Erosion does not create perfect circles. These objects are manufactured and they appear in rock layers 300 million years old, long before dinosaurs, the Carboniferous period, when Earth's atmosphere had 35% oxygen and dragonflies grew 3 feet wide. Something intelligent existed then, something with metallurgy, something that left these spheres behind. What were the spheres for? Nobody knows. Maybe tools, maybe decorative objects, maybe parts of larger machines now completely decayed. They survived because metal lasts. Everything else about the predecessors vanished, but these spheres remain, stubborn, impossible to explain away. Proof that we are not the first. The tunnels are stranger. Vast tunnel systems boring through solid rock. Perfectly circular cross-sections, walls showing tool marks, except the tool marks do not match any known drilling technique. The patterns suggest something melted the rock, or maybe dissolved it chemically. Advanced technology, more advanced than our current drilling methods. These tunnels appear on every continent. Some underwater, some under deserts, some beneath mountain ranges. They form networks, connect distant regions. No pattern obvious to us, but clearly deliberate. The predecessors built infrastructure. They moved between locations. They had reasons to tunnel through mountains. How old are the tunnels? Dating rock is difficult, but the tunnels cut through geological layers of known age. Minimum ages can be established. Some tunnels are at least 50 million years old, some possibly older. They predate every known human ancestor by tens of millions of years. Whoever built them, whatever they were, they mastered engineering on a massive scale. Ocean floor mapping revealed the most spectacular evidence. Vast geometric patterns on the seabed, lines, circles, grid formations, kilometers across, visible only from satellites, dismissed for decades as natural underwater formations, until high-resolution sonar revealed the details. These are not natural. They are too precise, too geometric, too deliberate. The patterns sit in areas of the ocean floor dated to 60 million years ago, formed during the Paleocene epoch, after the dinosaurs died. Before primates evolved, something existed then, something that built structures on the ocean floor, or built structures that later sank. Either way, evidence of engineering, evidence of civilization. Sampling the ocean floor patterns revealed something unexpected. The material is not natural rock. Chemical analysis shows artificial compounds, ceramics, metallic composites, materials that should not exist in nature. Somebody manufactured these substances, somebody created these structures, then the ocean swallowed them and time buried them under sediment. How many predecessor sites exist? Dozens discovered, probably thousands undiscovered, most buried under kilometers of rock, most invisible to our instruments, most erased by tectonic activity. We are finding the survivors, the tiny fraction that happened to be preserved by geological luck. Every few years, a new site gets discovered. Construction workers dig a foundation and find anomalous structures. Oil drilling penetrates strange chambers. A volcano exposes buried ruins. Each discovery adds another data point. Each data point makes the picture clearer. Earth had civilizations before us, multiple civilizations. Across deep time, the carbon anomaly is the smoking gun. Atmospheric carbon dioxide levels are recorded in ice cores and rock chemistry. Scientists can reconstruct Earth's atmospheric composition going back hundreds of millions of years. The data shows expected variations, ice ages, warm periods, volcanic eruptions, all matching geological models, except for the spikes. Sudden increases in atmospheric carbon dioxide that do not match any known natural process. Too fast for volcanic activity. Wrong chemical signature for meteor impacts. The spikes show the exact same isotope ratios as modern industrial pollution, fossil fuel burning. The predecessors burned coal or oil or something similar. They released massive amounts of carbon dioxide into the atmosphere. These carbon spikes appear at multiple points in Earth's history. The most prominent spike occurs about 56 million years ago, the Paleocene-Eocene thermal maximum. Scientists have always struggled to explain this event. Global temperatures jumped 5 to 8 degrees Celsius within a few thousand years. The traditional explanation involves volcanic activity and methane release, but the chemistry never quite matched until researchers realized it matched industrial pollution perfectly. The predecessors might have caused the Paleocene-Eocene thermal maximum, their industrial civilization pumping carbon into the atmosphere, just like we are doing now. The climate warmed, ecosystems collapsed, and the predecessor civilization collapsed with it. This is terrifying. It suggests industrial civilizations inevitably destroy themselves. It suggests we are following the same path they did. Other carbon spikes appear farther back, one around 120 million years ago, another around 200 million years ago, each spike suggesting industrial activity, each spike followed by rapid climate change. The pattern repeats. Civilizations rise, they industrialize, they pollute. The climate shifts, the civilization collapses. Then the planet heals, life continues, and eventually a new intelligent species evolves and starts the cycle again. We are not special, we are not unique. We are the latest iteration in a cycle that has played out multiple times. The predecessors came before us, something probably came before them. And if humanity destroys itself, something will probably come after us. This is the most humbling realization in scientific history, and most people have no idea. The silence is deafening. Why has this not made headlines? Why are textbooks not rewritten? Why does the public still believe humans are Earth's first civilization? The answer is complicated. Part scientific conservatism, part institutional inertia, part deliberate suppression. Scientists demand extraordinary evidence for extraordinary claims. Finding traces of previous civilizations is extraordinary. The evidence must be overwhelming, undeniable, beyond any possible alternative explanation. Many scientists believe we are not there yet. The data is suggestive, the patterns are compelling, but definitive proof remains elusive. So the debate continues in academic circles, while the public remains ignorant. Institutions move slowly. Textbooks take decades to update. Curricula require consensus. Museums need time to redesign exhibits. Even if the scientific community fully accepted the predecessor theory tomorrow, public education would take years to catch up. So children still learn the old story. Humans invented civilization. We are the first. We are special. Then there is the suppression angle. Some researchers claim evidence has been deliberately hidden. Discoveries filed away, papers rejected, funding denied. Why would anyone suppress this information? Several possibilities: religious implications, political instability, economic disruption. If humanity is not special, if we are just the latest in a series, it undermines certain worldviews. Some people do not want that challenge. Maybe the suppression is about control. Governments and institutions benefit from the current narrative. Humans as the crown of creation, the apex of evolution, destined to spread across the stars. If we are just another species in a repeating cycle, destined to collapse like those before us, it raises uncomfortable questions about authority and power. Or maybe there is no suppression. Maybe it is just slow scientific progress. Either way, the evidence exists. The patterns are there. The predecessors were real. And eventually, the truth will become common knowledge. The question is how long that takes and what happens when everyone knows. The isotope ratios do not lie. When you burn fossil fuels, you release carbon with a specific isotopic signature. This carbon is depleted in the carbon-13 isotope compared to atmospheric carbon dioxide. The depletion creates a fingerprint. Modern industrial activity shows this fingerprint clearly. So does the geological record at specific times in Earth's history. The predecessors burned fossil fuels, probably coal, maybe oil, definitely something organic and ancient. Their industry left the same isotopic signature we leave today. This is the most convincing evidence. Chemistry does not lie. The ratios are there. In the ice cores, in the rock layers, in the fossilized organic material. Industrial civilization existed before humans. How advanced were they? More advanced than early human civilization. Less advanced than modern humans in some ways. Maybe more advanced in others. The evidence suggests they had metallurgy, engineering, chemistry. They built cities, created infrastructure, conducted large-scale mining and fuel extraction. This requires a certain baseline of technology. but they did not have everything we have. No evidence of plastics comparable to modern polymers. No evidence of radioactive materials. No nuclear testing signatures. Either they never developed these technologies, or the evidence has decayed beyond detection. Plastics break down eventually. Radioactive isotopes have half-lives. Given enough time, even these traces vanish. The predecessors probably went through a similar technological progression as humans. Stone tools, bronze, iron, steel, industrial revolution. But their timeline might have been completely different. Maybe they took 1,000,000 years to progress from stone to steel. Maybe they did it in 10,000 years. We have no way to know. We only see the snapshots, the frozen moments preserved in rock. One haunting possibility. The predecessors might have been more advanced than us. They might have reached our level of development and kept going, developed technologies we have not imagined yet, then collapsed anyway. If true, it suggests technological advancement does not save civilizations. The same forces that destroy primitive societies also destroy advanced ones. We are not progressing towards safety. We are just getting different tools. The extinction events align too perfectly. Earth has experienced 5 major mass extinctions in the past 500 million years. The Ordovician, the Devonian, the Permian, the Triassic, the Cretaceous. Each event wiped out huge percentages of life. The traditional explanations involve volcanism, meteor impacts, and climate change. But what if some extinctions had another cause? What if the predecessors caused their own extinction? Industrial pollution, climate change, environmental collapse. Their civilization destroyed the ecosystems they depended on. This triggered a mass extinction. Not just the predecessors died, everything else did too. The entire planet paid the price for their industrial activity. The Permian extinction fits this pattern. About 252 million years ago, 90% of marine species went extinct. 70% of terrestrial vertebrates. Nearly all life on Earth died. Scientists blame massive volcanic eruptions in Siberia, but the eruptions alone do not explain the scale. Something else contributed. Maybe an industrial civilization pumping pollution into an already stressed environment, the combination proving lethal. Chemical traces from the Permian boundary show anomalies, unusual heavy metal concentrations, carbon signatures suggesting fossil fuel burning. The timing matches the extinction perfectly. Did the predecessors cause the worst extinction in Earth's history? We cannot prove it, but the correlation is disturbing. If true, it means industrial civilizations are planetary disasters. They inevitably poison the environment. They trigger mass extinctions. They destroy themselves and take everything else with them. We are currently following this exact pattern. Carbon emissions rising, ecosystems collapsing, species going extinct at accelerating rates, history repeating. The predecessors are a warning. This is what happens to industrial civilizations. This is where our path leads. Unless we change course, unless we learn from their mistake. But learning requires acknowledging they existed, and most of humanity still does not know. Time erases everything. This is the fundamental problem with detecting ancient civilizations. Every trace decays, every structure crumbles, every chemical signature fades. The older the civilization, the less evidence remains. After 10 million years, almost nothing. After 100 million years, you would be lucky to find anything at all. This is called the Silurian hypothesis, named after a science fiction species, the Silurians. The hypothesis asks, how would we detect an industrial civilization that existed millions of years ago? What traces would survive? The answer is disturbing. Very few traces, maybe none. Wood rots in centuries, paper in decades, plastics break down in thousands of years, metals oxidize and crumble, glass shatters, even stone erodes. The pyramids are 4,500 years old and already deteriorating. What will they look like in a million years? Dust, indistinguishable from natural rock formations. Concrete is even worse. Modern concrete lasts maybe 100 years before significant degradation. Ancient Roman concrete does better, but even that crumbles over millennia. After 10,000 years, no concrete structures would be recognizable. After 100,000 years, nothing left. The foundations of our cities would vanish into the geological record. Ceramics survive longer, pottery shards last thousands of years, but they are fragile, break easily, scatter after millions of years. Even ceramics would be ground to dust by geological processes. Tectonic activity, erosion, sediment deposition, everything gets crushed and buried and mixed together. The only things that survive deep time are chemical signatures and large-scale geological modifications, isotope ratios, pollution markers, and the absolute most durable structures. Those tunnels through mountains might last, those ocean floor patterns might persist, but buildings, roads, vehicles, all gone, completely erased. This means the predecessors we are detecting probably were not the first. They might have been the 10th, the 100th, each previous civilization rising and falling and leaving almost no trace. Only the most recent ones left enough evidence to detect. The earlier ones vanished completely. How many civilizations existed before the predecessors? We will never know. The Silurian hypothesis has profound implications for the search for extraterrestrial intelligence. If ancient civilizations are nearly impossible to detect on Earth, they would be absolutely impossible to detect on other planets. We look for alien radio signals, alien structures, alien modifications to their stars. But what if alien civilizations only last 1 million years? What if they collapse before developing interstellar technology? The universe is 13.8 billion years old. Plenty of time for countless civilizations to rise and fall. But if each one only lasts a blink in cosmic time, we would never see them. They would appear, burn brightly, collapse, and vanish, leaving no trace, no signal, no evidence they ever existed. The universe could be filled with the ghosts of dead civilizations, and we would never know. This is the dark answer to the Fermi paradox. Where is everybody? They existed, they destroyed themselves, and now they are gone, erased by time. We are not seeing aliens because aliens do not last. Civilizations are temporary, brief, fragile, and the evidence of their existence decays faster than new civilizations appear. Humanity might be alone in the universe right now, not because intelligence is rare, but because it is short-lived. We are the current spark, temporary, destined to burn out like all the others, unless we learn, unless we change, unless we break the cycle. The cycle is the terrifying part. Intelligence evolves, develops tools, discovers fire, invents agriculture, builds cities, industrializes, pollutes, collapses. This pattern might be inevitable, written into the nature of complex systems. Intelligence requires energy. Industrial civilization unlocks vast energy sources, but using those energy sources destroys the environment. The system contains its own destruction. The predecessors followed this pattern. Evidence suggests multiple collapses. They industrialized, climate changed, their civilization fell, the survivors regressed to pre-industrial life. Then thousands or millions of years later, they rebuilt, industrialized again. collapsed again, the cycle repeating until finally a collapse so severe they went extinct entirely. We are in the industrialization phase, carbon emissions rising, temperatures increasing, ecosystems failing. Every indicator shows environmental collapse approaching. We know this, we measure it, we predict it, yet we continue, just like the predecessors did. The cycle is hard to break because industrial civilization is addictive, comfortable, powerful. Giving it up voluntarily seems impossible. Maybe every civilization faces this test. Can they industrialize without destroying themselves? Can they find sustainable energy? Can they limit their impact? Most fail. The geological record suggests repeated failures. The predecessors failed multiple times. Now humanity faces the same test, and we are currently failing, but there is hope. We know the danger. We can study the predecessors' mistakes. We can see where their path led. Knowledge is power. If we recognize the cycle, maybe we can break it. Maybe we can become the first industrial civilization to survive, the first to pass the test. The test is planetary management. Industrial civilization generates waste, heat, pollution, disruption. Managing these impacts requires deliberate effort. Technology alone is not enough. You need social organization, cooperation, long-term thinking, the ability to prioritize survival over short-term gain. This is incredibly difficult, maybe too difficult, but it is the only way through. The predecessors probably faced the same choice: continue polluting and collapse, or change course and survive. They chose collapse, or maybe they tried to change and failed. Either way, the outcome was extinction. We are at the same crossroads. The next 100 years will determine which path humanity takes. There is no middle ground. Either we survive or we do not. The deep time perspective is humbling. Humans have existed for maybe 300,000 years. Civilization for 10,000 years. Industrial civilization for 200 years. These are eye blinks, irrelevant on geological timescales. Yet we think we are permanent. We build monuments. We plan centuries ahead. We assume humanity will last forever. The predecessors probably thought the same thing. They built their cities, developed their technology, assumed they were permanent. Then they vanished. Now only faint traces remain. Chemical signatures, anomalous structures, evidence so subtle we almost missed it entirely. In another 100 million years, even these traces will fade. The predecessors will be truly gone, erased from history. Humanity is heading toward the same fate, unless we change course, unless we survive the collapse, unless we find a way to maintain civilization while protecting the planet. It is possible, theoretically, but evidence suggests it is rare, maybe vanishingly rare. Maybe we are not capable of it. The brain structure problem might doom us. Human brains evolved for short-term thinking, immediate threats, immediate rewards. We are terrible at long-term planning. Climate change happens over decades, too slow to trigger our danger instincts. We see the data, we understand the risk, but emotionally it does not feel urgent. So we delay, we postpone, we continue polluting. The predecessors probably had the same problem. Whatever their brain structure, it evolved for survival in their natural environment, not for managing planetary systems. They understood the danger intellectually, but they could not emotionally prioritize it. So they kept industrializing until it was too late. This might be a universal trap. Intelligence evolves to solve local problems, hunting, foraging, social navigation. These skills do not translate to planetary management. You need different cognitive tools, different emotional responses. Maybe some alien species evolved these tools naturally. but most probably did not. Most probably faced the same trap as us and the predecessors. If so, the universe is full of dead worlds, planets where intelligence evolved, industrialized, and collapsed, the life cycle of civilizations playing out on countless worlds, most failing, the fossils of their cities buried under rock, their chemical signatures fading, their existence forgotten. We are not special, we are just the current example. Finding predecessor artifacts would change everything. Chemical signatures are convincing to scientists, but the public needs something tangible, a tool, a structure, a machine, something that proves beyond doubt the predecessors existed. So far, we have not found that smoking gun artifact, but we might. Someday. The deep drilling projects offer hope. Several research teams are drilling into anomalous geological formations, targeting the buried structures, trying to recover physical samples. If they find manufactured materials, isotope analysis will date them. Chemistry will reveal their composition. If the materials are millions of years old and clearly artificial, the debate ends. The predecessors become established fact. Ocean floor excavations are another possibility. The geometric patterns on the seabed contain material, probably ceramic, maybe metal. Recovering samples requires underwater drilling. Expensive, difficult, but possible. Several missions are planned. Within the next decade, we might have physical predecessor artifacts in laboratories. Analyzed, dated, proven. What would such an artifact look like? Probably nothing impressive to untrained eyes. A chunk of corroded metal, some strange ceramic material, chemical residue. Scientists would see the significance immediately, but to the public, it would look like garbage. Explaining why this garbage proves ancient civilizations existed would be the challenge. Maybe we will find something more obvious, a tool, a structure, something recognizably artificial. This would make convincing people easier, but the probability is low. Anything that obvious probably would have been found already. The predecessors' artifacts are subtle, hidden, nearly erased. That is why they stayed hidden so long. Perhaps the most valuable artifact would be their knowledge. Did the predecessors develop writing, information storage? If so, traces might exist. Encoded in durable materials, ceramics, metal, stone. We should look for information storage, patterns that seem artificial, regular, deliberately organized. This would be the ultimate proof and the ultimate warning. Their recorded history showing what happened, why they collapsed, what mistakes they made. Imagine finding a predecessor library stored on some medium we have not thought to check. Their entire history, their science, their culture, their warning to future civilizations. We are heading toward collapse. We cannot stop it. This is how civilizations end. Do not make our mistakes. Such a message would change everything. It would prove the predecessors existed, and it would force humanity to confront our own trajectory. But maybe they left no records. Maybe their writing materials all decayed. Maybe they never developed writing. Maybe they did leave records, and we destroyed them unknowingly. Mining operations, construction projects. We dig through ancient rock layers constantly. If predecessor artifacts existed there, we probably crushed them and never noticed. The evidence might have been destroyed before we knew to look for it. This is the tragedy of deep time. Everything is lost eventually. Knowledge, culture, memory, all of it dissolves into geological processes. The predecessors built a civilization. They had art, music, literature, philosophy, all gone, erased. Only the faintest chemical traces remain. Their entire existence reduced to anomalous isotope ratios. Humanity's fate might be identical. If we collapse and a new species evolves millions of years later, what will they find? Chemical signatures of industrial pollution, maybe some tunnels, some geometric patterns on the ocean floor. Nothing else. Our art, gone. Our literature, gone. Our science, gone. All our achievements reduced to the same faint traces the predecessors left. This makes the search for predecessor knowledge urgent. If they left any information storage, any records, we need to find them before geological processes erase them completely. Every year that passes is another year of decay, another year of erosion. The clock is ticking, the evidence is fading, and we might only have one chance to recover it. The religious implications are profound. Most religious traditions assume humanity is special, created by divine forces, given dominion over Earth, destined for some cosmic purpose. The predecessor theory challenges all of this. We are not special. We are not the first. We are not unique. We are just another species in a long line of intelligent species that evolved, flourished briefly, and vanished. This is not necessarily incompatible with religion. Maybe the divine creates intelligence repeatedly. Each species gets its chance. Each one faces the same test. Most fail. Some might succeed. From this perspective, the predecessors are our predecessors in a literal sense. They came before us in the divine plan. We can learn from their failure. We can honor their existence by succeeding where they failed. But traditional religious narratives need revision. Stories about human origins, about our special role, about the beginning of civilization. All of these stories are incomplete at best, wrong at worst. Religious institutions face a choice: adapt to the new evidence, incorporate the predecessors into theology, or deny the evidence and become increasingly irrelevant as proof accumulates. Some religious thinkers embrace the predecessor theory. They see it as humbling, a reminder that humanity is part of nature, subject to the same forces as every other species. Our survival is not guaranteed. We must earn it through wisdom and action. This perspective makes religion relevant to the survival challenge. It provides moral frameworks for planetary stewardship. Others reject the theory entirely. They call it speculation, misinterpretation of data, attacks on faith. For these believers, humanity must be first, must be special. The alternative is unthinkable. This denial creates problems. As evidence accumulates, denial becomes harder to maintain. Young people especially reject institutions that deny obvious reality. The choice is adapt or lose relevance. The philosophical implications might be more profound than the religious ones. The predecessors prove that intelligence is temporary. Civilizations rise and fall. This is not speculation, not theory. It is observed fact recorded in Earth's geological record. What does this mean for meaning, for purpose, for human aspirations? If we are destined to collapse like the predecessors, what is the point? Why build? Why create? Why struggle to maintain civilization if it is all temporary anyway? This is the existential crisis the predecessor theory creates, not for everyone. Some people find meaning in temporary things, but for others, impermanence destroys motivation. Perhaps the point is to break the cycle, to become the first industrial civilization that survives. This would give humanity unique meaning. We are not just another iteration, we are the breakthrough, the species that learned, that changed, that passed the test. This goal is worth pursuing, worth sacrificing for, worth dedicating civilization to achieving. Or maybe the point is the journey. Civilizations might be temporary, but while they exist, they create beauty, article, music, literature, love, joy, experience. These things have value even if they are temporary. We do not need permanence to justify existence. We just need to exist fully while we have the chance. The predecessors probably grappled with the same questions. When they realized their civilization was collapsing, what did they think? Did they despair? Did they rage against fate? Did they accept it peacefully? We will never know. Their thoughts died with them. But we can imagine, we can feel connected to them across the vast gulf of time. They faced what we are facing. They felt what we are feeling. They are us. Just earlier in the cycle, the political implications are explosive. If the predecessor theory becomes widely accepted, power structures shift. National governments justify authority through historical narratives. We built this civilization. We maintain order. We protect progress. But if civilization is temporary, if collapse is inevitable without major changes, these justifications weaken. Revolutionary movements could use the predecessor theory. We are repeating their mistakes. Current leaders are driving us toward collapse. We need radical change now, before it is too late. This is politically powerful messaging. It frames current political disputes as life and death struggles. Compromise becomes betrayal. Gradualism becomes suicide. Conservative forces would resist. They always do. Change threatens existing power. The predecessor theory threatens the foundations of industrial capitalism. Endless growth, resource extraction, profit maximization. These principles drove the predecessors to extinction. They are driving us the same direction. Admitting this requires abandoning the current economic system. Most leaders will not do that willingly. International cooperation becomes essential. The predecessors probably had nations, competing groups, political divisions. These divisions prevented coordinated response to the crisis. Each group pursued its own interests. Nobody took responsibility for the whole planet. By the time they tried to cooperate, it was too late. The collapse was already unstoppable. Humanity faces the same coordination problem. Climate change is global. Pollution is global. Ecosystem collapse is global. But our political systems are local. Nations compete. They prioritize domestic concerns. They defect from international agreements when convenient. This guarantees failure. Unless we solve the coordination problem, we follow the predecessors into extinction. The predecessor theory could motivate cooperation. Look what happened to them. Division led to collapse. Unity is our only chance. This argument might break through political barriers, might create the common purpose needed for survival, or it might not. Political tribalism is powerful. Even existential threats do not always overcome it. Economic transformation is unavoidable. Industrial capitalism depends on growth, constant expansion, more production, more consumption, more extraction. This worked for a while, but it cannot work forever. The planet is finite, resources are limited, waste accumulates. Eventually, the system hits limits. The predecessors hit those limits. So will we. The evidence suggests the predecessors tried to maintain growth past sustainable limits. They depleted resources, damaged ecosystems, polluted critical systems. The pollution feedback loops triggered runaway climate change. Their civilization could not adapt fast enough. The infrastructure of industrial society requires stability. Rapid climate change destroys that stability. Food systems fail. Supply chains break. Social order collapses. We are approaching the same limits. Some resources already depleting. Ecosystem services already degraded. Climate already changing. We have maybe a generation to transform our economic system, shift from growth to sustainability, from extraction to regeneration, from waste to circular systems. This is possible technically, but politically, the obstacles are enormous. Wealth inequality complicates everything. The richest humans consume vastly more than the poorest. Their carbon footprints are hundreds of times larger. Any solution to the sustainability crisis requires addressing inequality. The wealthy must consume less, much less. They will resist. They benefit from current arrangements. Why would they voluntarily give up privilege? The predecessors probably faced similar inequality. Every complex society develops hierarchies, concentrations of wealth and power. The elite class probably consumed disproportionately, probably resisted changes that threatened their status, probably maintained unsustainable practices until the very end because those practices benefited them personally. Their selfishness doomed everyone. Human psychology makes inequality persistent. We evolved in small groups. Status hierarchies were face to face. Extreme inequality was impossible because everybody knew everybody. Modern societies broke that constraint. We can accumulate arbitrary amounts of wealth, never see the people we harm, never face the consequences of our consumption. This psychological distance enables the exploitation that drives environmental collapse. Breaking this pattern requires either cultural revolution or institutional design. Cultural revolution means changing values, making sustainability sacred, making excessive consumption shameful, making collective well-being the highest goal. This is hard. Values are sticky. They resist change, but possible. Cultures have transformed before. Institutional design means creating systems that align individual incentives with collective survival. Carbon taxes, resource limits, wealth caps, mandatory sustainability standards force people to act collectively even if their values have not changed. This is also hard. The powerful block institutional change, but maybe not impossible if the alternative is civilization collapse. The predecessors probably tried both approaches. Some individuals probably argued for change, warned about coming disaster, proposed solutions. Most people probably ignored them, dismissed them as alarmists, continued business as usual until too late. We see this pattern today. Climate scientists warn, activists protest. Most people acknowledge the problem, but do not change behavior. History repeating. The difference is we know about the predecessors. We have proof that industrial civilizations collapse. This knowledge might break through denial, might create urgency, might motivate action, or it might not. Knowledge alone rarely changes behavior, but combined with visible environmental degradation, maybe it is enough. Maybe seeing the pattern makes people realize this time is different. This time, we need to change. Time is the critical factor. How long do we have? Decades, maybe a century if we are lucky. This sounds like a lot. It is not. Social systems change slowly. Economic transformations take generations. We need rapid change on timescales societies rarely achieve. The predecessors probably ran out of time. They saw the crisis coming, but moved too slowly. Political gridlock, economic inertia, psychological denial. By the time they achieved consensus on solutions, the climate had already shifted beyond the tipping point. We might already be past the tipping point. Some climate scientists think so. The feedback loops already activated, methane releasing from permafrost, ice sheets melting irreversibly, ocean currents shifting. Each change amplifies others. Even if we stopped all emissions tomorrow, warming might continue for centuries. We might have triggered collapse already without realizing it, but we do not know for certain. Maybe we still have time. Maybe aggressive action now could stabilize the system. The predecessors left no records of their attempts to avert collapse. We do not know if they tried and failed or never tried at all. Maybe they could have succeeded if they acted earlier. Maybe we still can. The search for predecessor survivors is haunting. Did any of them survive the collapse? Small populations persisting in isolated regions, reverting to pre-industrial lifestyles, living on for thousands or millions of years before finally going extinct. The evidence is unclear. Some geological sites suggest isolated pockets of activity continuing after the main collapse, but these might be artifacts of dating uncertainty. If survivors existed, they left even fewer traces than the main civilization. Small populations have limited impact. They would not show up in global chemical signatures, would not build structures large enough to survive deep time. They would be invisible to our detection methods. They might have existed for 1,000,000 years, and we would never know. Human survivors of our collapse would face similar constraints. If industrial civilization falls, survivors would lack technology, lack infrastructure, lack the population to maintain complex systems. They would regress to simpler lifestyles, hunting, gathering, small-scale agriculture. These activities leave minimal archaeological traces. Future intelligent species might find our industrial era traces, but completely miss the post-collapse survivors. This is the long-term risk, not extinction necessarily, but permanent loss of industrial capacity. The predecessors used up the easily accessible fossil fuels, the surface coal, the shallow oil. When those ran out and civilization collapsed, survivors could not rebuild industrial society. The remaining fossil fuels required advanced technology to extract, technology the survivors no longer possessed. They were stuck at pre-industrial tech levels permanently. Humanity might face the same trap. We are using the easy resources. Once they are gone, rebuilding becomes impossible. Post-collapse survivors could not restart industrial civilization. They would lack the accessible energy needed to bootstrap technology. Earth would be permanently limited to pre-industrial civilizations, unless intelligence evolved again in the far future and found different energy sources. Renewable energy offers hope. If we transition to solar, wind, hydroelectric before collapse, survivors might maintain some technology, enough to eventually rebuild. But this requires building renewable infrastructure now, before the collapse. After collapse, we cannot build solar panels, cannot manufacture wind turbines. The industrial capacity is gone. The predecessors might have missed this opportunity, might have stayed dependent on fossil fuels until the end, never transitioned to renewables, or tried too late. Their collapse was total. No survivors with advanced technology, no pathway back to industrial civilization, permanent loss. We have a chance they may not have had. We know collapse is possible. We can prepare, build resilient systems, preserve knowledge, create tools for recovery. Even if industrial civilization falls, we can design it to fall softly, to leave survivors with resources and knowledge to rebuild. This is the best-case scenario, not avoiding collapse entirely, but ensuring survival through it. The knowledge preservation problem is critical. If civilization collapses, most information will be lost. Digital storage requires infrastructure, power, maintenance. When infrastructure fails, data vanishes. Books decay over centuries. Only the most durable information storage survives. Stone, metal, ceramic. We should be encoding critical knowledge in durable forms now. Instructions for future survivors. How to rebuild. What mistakes to avoid. The predecessors might have tried this, those metallic spheres. Maybe they are information storage, encoded somehow. We have not figured out how to read them. If we could, they might contain the predecessor's warning, their entire history compressed into durable form. This is speculation, but worth investigating. We should examine those spheres more carefully, look for patterns, information density, anything suggesting deliberate encoding. Imagine finding their warning, reading their account of the collapse, seeing exactly what went wrong, what decisions led to disaster, what alternatives existed, what they wish they had done differently. This would be the most valuable knowledge in human history. A roadmap showing both the path to destruction and the path to survival. We should be searching for this desperately. But even without finding predecessor records, we can learn from their example. The geological record is a message. Industrial civilization causes detectable pollution. That pollution correlates with climate disruption. Climate disruption leads to mass extinction. This is what happened to them. This is what is happening to us. The pattern is clear. The warning is obvious. We just need to listen. The next 100 years will determine human fate. Either we break the cycle or we repeat it. Either we become the first industrial civilization to survive, or we join the predecessors in extinction. There is no middle ground, no muddling through. The stakes are absolute. Everything depends on choices we make right now. Future humans, if they exist, will look back at this moment. They will study our decisions like we study the predecessors. Did we act in time? Did we transform our systems? Did we prioritize survival over comfort? Or did we repeat the same mistakes? Did we choose short-term gains over long-term existence? Did we fail the test? The predecessors failed. Multiple times across deep time, they rose, they industrialized, they collapsed. The cycle repeating until finally, total extinction. We are in the same cycle now. Same pattern, same dangers, same choice point. The only difference is we know, we have their example, we can see where this path leads. Knowledge is not enough. Action is required. Immediate, radical, transformative action. We need to restructure civilization in decades. Change economic systems, change power systems, change value systems. This is unprecedented. No society has ever transformed this quickly, voluntarily, but the alternative is collapse. So we must try. The predecessors teach us that intelligence is not enough. Technology is not enough. You need wisdom, foresight, collective discipline, the ability to act against short-term interests for long-term survival. These qualities are rare, maybe vanishingly rare. Maybe intelligence without wisdom is a cosmic dead end. Maybe that is why the universe seems empty of civilizations. They all follow the same path, brief flourishing, then collapse, then silence. We can break this pattern. Theoretically, we have the knowledge, we have the technology, we even have the resources if we allocate them correctly. What we lack is collective will, the political coordination, the cultural transformation, the moral courage to change course while change is still possible. The clock is ticking. Each year of inaction narrows our options. Each year of continued pollution pushes us closer to irreversible tipping points. The predecessors probably watched their own countdown, knew time was running out, could not act fast enough. We are watching the same countdown now. Can we act faster than they did? Can we succeed where they failed? The evidence suggests intelligence evolves repeatedly. The predecessors are proof. They were not human. They were something else entirely. But they developed civilization, technology, industry, the same trajectory from different origins. This means intelligence is probably common in the universe. Life finds a way. Given enough time, neurons organize into consciousness. Consciousness develops tools. Tools enable civilization, but the evidence also suggests intelligence is fragile, temporary, self-destructive. Industrial civilization generates its own demise. The system contains failure modes. The more advanced you become, the more you damage the foundation supporting you. Intelligence is smart enough to build complex systems, not smart enough to manage the consequences. This might be universal, a fatal flaw in consciousness itself. If so, the universe is filled with failed civilizations, brief sparks of complexity in the cosmic darkness, rising, burning, extinguishing on every world where life evolves, where intelligence emerges. The same pattern plays out, the same tragic arc, beginning to flourishing to collapse, over and over, throughout cosmic history. We are not witnessing something unique. We are participating in a universal pattern. This makes our moment cosmically significant, not because we are special, because we are typical. What happens to humanity happens to intelligence generally. If we fail, it suggests all intelligence fails. The filter is insurmountable, but if we succeed, if we somehow break the cycle, we prove success is possible. We become the proof that intelligence can survive its own cleverness, that civilizations can achieve sustainability, that the pattern can be broken. We are not just fighting for human survival, we are fighting for the possibility of intelligence itself, for the idea that consciousness has a future, that complexity can persist, that the universe can contain more than brief sparks of awareness quickly extinguished. This is the ultimate stakes, not just our survival, but the survival of meaning, of purpose, of the possibility that intelligence matters. The predecessors fought this fight. They lost, but they teach us the battle is real. The danger is not theoretical. Collapse actually happens. We have proof. Their failure should motivate us, should create urgency, should break through the denial and complacency that dooms civilizations. Will it work? Will knowledge of the predecessors change human behavior? Will seeing their failure help us avoid the same fate? These questions remain unanswered. The experiment is ongoing. We are living through it right now. The next decades will tell the story. Either we adapt or we collapse. Either we learn or we repeat. The choice is ours. The predecessors cannot help us anymore. They are gone, erased by time. Only their faintest traces remain. Chemical signatures in ancient rock, geometric patterns under the ocean, anomalous structures buried deep. These traces are messages, warnings from the deep past. Previous intelligence existed here. Previous civilization rose here, and previous collapse destroyed everything here. Listen to the warning. The predecessors were real. They failed. Their world ended. Their species died. Everything they built vanished. Only rocks remember them now. This can happen. This will happen, unless we change course, unless we break the cycle, unless we become the first industrial civilization to pass the test. 200,000 light years is not just a number. It is the scale of our galaxy, our home, the stage where human drama unfolds. But 200 million years is the scale of the predecessors, the deep time perspective, the geological time scale where civilizations rise and fall like seasons, where intelligence flickers briefly and vanishes, where Earth cycles through consciousness, trying again and again to produce a species wise enough to survive. We are the current attempt, the latest iteration, Earth's newest experiment with industrial intelligence. The predecessors were previous attempts, failed attempts. We have the chance to be different, to be the success story, to prove that intelligence can survive, but only if we act, only if we learn, only if we change. The evidence is there, the pattern is clear, the warning is obvious. Previous civilizations collapsed. We are next unless we transform. This is not speculation, this is not theory, this is geological fact recorded in Earth's rocks. The chemistry does not lie, the structures do not lie. The predecessors existed, and they are warning us. Will we listen? Will humanity acknowledge the message? Will we accept that we are not first, that we are not special, that survival requires changing everything about how civilization works? The answer determines our future, determines whether human consciousness continues or joins the predecessors in extinction. The choice is now. The moment is critical. The stakes are absolute. We stand at the crossroads the predecessors faced. One path leads to survival, transformation, breaking the cycle. The other path leads where theirs led, to collapse, to extinction, to becoming another set of anomalous chemical signatures in the geological record, another failed attempt at sustainable intelligence. This is the story of the predecessors, the civilization before us, the intelligence that rose and fell, the warning written in rocks. They existed, they built, they failed, and they are teaching us the most important lesson in history. Industrial civilization is not guaranteed to survive. It must be fought for, protected, transformed, or it will collapse, just like theirs did. We are not the first. We might not be the last, but we could be the first to survive, the first to break the pattern, the first to prove that intelligence has a future, that consciousness can persist, that civilization can endure. This is the challenge the predecessors left us. This is the test we must pass. The clock is ticking, the planet is warming, the ecosystems are failing, the countdown is underway, just like it was for them. They ran out of time. Will we, or will we become the exception, the breakthrough, the species that learned from the past and changed the future? History is watching, not just human history, cosmic history, the long story of intelligence in the universe. What happens here matters. What we do now echoes through deep time. The predecessors failed their test. We are taking ours. The question is simple but profound. Can intelligence survive itself? Can civilization outlast its own success? Can we break the cycle? The predecessors could not. Their traces remain as evidence, as warning, as challenge. They were real, they failed, we are next. And everything depends on what we do now, right now, in this generation. At this moment in Earth's long history, we are not the first civilization on Earth, but we could be the first to survive. The choice is ours. The time is now. And the predecessors are watching from deep time, waiting to see if we learn from their mistakes or repeat them. This is the biggest story in human history, and most people have no idea yet.